All right, IBSL1, we finally made it to the end of Chapter 3. So we are going to do Chapter 3, Close Your Notes. You guys, this chapter was split into two targets. One of them was a transformations target, and the second one was quadratics. Let's talk transformations. All right, let's talk close your notes in general. I'm not going to go through and redo every single little part that we've done from notes. I'm just going to talk about the big bullet points. So there's a lot of finer things that should go with these that you should go back and study in your notes from before. Know how to translate functions. That means moving it left, right, up, and down. Horizontal movements, vertical movements. Remember, the horizontal is inside the function, and it's always backwards. Like a x minus 3 inside actually pushes it to the right 3. Reflections over the x-axis, that would be putting a negative on the outside of the function, and reflections over the y-axis would be putting a negative inside the function. Remember that negatives usually inside the function usually has to do with horizontal things, and outside the function usually has to do with vertical things. Dilations, those are stretching and compressing. We did that both horizontally and vertically. Remember that with the vertical, it works at the way you want it to. Numbers bigger than 1 actually stretch it up and down, and numbers in between 0 and 1, like fractions and decimals, they squish it, they compress it from the top and the bottom. But the horizontal is the exact opposite. Numbers bigger than 1 actually compress it, and numbers in between 0 and 1 actually stretch it horizontally. The main thing that your book focused on transforming were parabolas and then some of those step functions. If you don't know what I mean by step functions, I mean something like, that you could take this shape and then, if you knew what the coordinates were, that you could do, and if this was f of x, that we could ask you to transform it in certain ways and you could sketch a new picture of what it looks like. Quadratics. So I've got to switch up my highlighter. Let's go gray. There was 3 main forms of quadratics: vertex form, general form, and factorized form. Now, we could give you any of those 3, and you should be able to find the axis of symmetry, the vertex, the x-intercepts, and be able to sketch the graph. Most of these things you should be able to do algebraically and should not have to reach for a graphing calculator for. But, we're not going to take those away. Just know that if it says find the exact vertex or exact x-intercept, that decimal approximations would not be okay. They wouldn't get you the full points. Solving quadratics. We revisited factoring. Remember, we did some small factoring, baby factoring, which is pulling out a common monomial. Simple factoring is finding 2 things that multiply to the end and add to the middle. And then advanced factoring is when you have that a value that's bigger than 1. Remember, the smoke and mirrors process can help you factor those harder ones. You should also know how to complete the square, sing the song, half the middle coefficient squared, and then add it to both sides. That's the main thing there. Quadratic formula. You have multiple songs you can sing for that one. I would know what the discriminant is, and when it's negative, that there's 0 solutions. When it's equal to 0, there's 1 solution, and when it's positive or greater than 0, there are 2 solutions. Just with this 0 solution situation, that means that the discriminant was negative or was less than 0, and that I guess with all 3 of these you could use solving inequalities, which involved zone testing. I highly encourage zone testing every time there's an alligator involved with a quadratic. All right, you guys.